Okay, and now for example 2, here's our circuit. Here's how we calculate the time constant, which is part B. The switch is now closed. So if we close the switch, calculate the maximum charge on the capacitor. So 1, Qmax is C times V, or C times the EMF of the battery. So that's going to be 12 times 5 times 10 to the negative 6. So that's going to be 600 microcoulombs. And then also 2 now is the maximum current through the resistor. So 2 Imax is going to be the EMF over the resistance. So that's 12 volts divided by 0.85 mega ohms. And that'll be about 14.1 microamps. Right. Now this is good. We found these. These are going to be our coefficients in our equations, right? And so then for 3 it says charge is a function of time. Right. So charge is a function of time. Charge is something that's decreasing. So we start with charge. What am I doing? Would be Q. Q is something that's increasing, right? And so that's the charge collecting on the capacitor. So that's going to be this, 600 microcoulombs times 1 minus e to the negative t over 4.25, which is the time constant. And then 4 is asking for current as a function of time. 4, current as a function of time is going to be this, 14.1 microamps. This is something decreasing, so e to the negative t over tau, where tau is 4.25. And those are our functions. The charge on the capacitor after 1 time constant, you take this, and after 1 time constant, the charge is 63%. So you just find 63% of 600. And I have that number. It's 0.378 microcoulombs, which doesn't really make much sense, because that does not look like 63% of that. Let's see. It's got to just be 378 microcoulombs. Maybe it was 0.378 nanocoulombs. And then the current is going to be 37% of that after 1 time constant, which is, I think, about 5.22 microamps. Now we want the graphs. So the graph of Q versus T charge looks like this. Okay, and this, Q max, is 600 microcoulombs. Okay, and then the current as a function of time is going to be decreasing, and this starts off at 14.1 microamps. Okay, so that's example 2.